Okay, so we're back at CodeFights again, the arcade section, level 2, and we're looking at the algorithm century-from-year. So let's read the description. Given a year, return the century it is in, right over here. This is pretty much everything that we need to know. So we have a parameter of year, so we're going to put in a year, any year that we want, and we want to return the century of that year. So to do this, what we're going to do, first off, we're going to write down return. And if we like to get the century, basically we need the first 2 digits, for example, of a 4-digit year. Or if it was 3 digits, then it would be a 1-digit number, right? So what we're going to do that is we're going to type down year divided by 100. And let's break out the calculator for a second. So say our year was 1900, right? Divide 1900 by 100 and you would get 19. Year 200, divide that by 100, you would get the second century, right? But even though it works with numbers like those, you know, like 200, 300, 400, 500, 1,000, 2,000, 3,000, 4,000, 5,000, so on, it's not going to work with numbers like this. So let's say our year, for example, 2017. What would you think would happen if we divided this by 100? It would give us a decimal. And, you know, that's not going to work out, you know. Centuries are in decimals. And with that said, let's take a deeper dive into this. So we're going to go over to, oh wait, hold up. Let me erase all of this because you don't need to see this right now. Okay, so let's go back and let's start off with year 1 to 100. So 1 to 180. So those would be, that would be the first century. Those years would be the first century. Bear with me, I just got this tablet. Right? So let's go over to the next century. So the second century. I gotta go slower with the tablet because I'm recording at the same time. So 101 to 200, that would be the second century. And let's take a deeper dive into this, this right here, the second century right here. I'm not going to output all the numbers. I'm just going to put in the first 5 because, you know, that would take too long. So 101, 102, 103, 104, 105. And look at these ones at the beginning of each of the numbers. So say that you are like a 7-year-old kid just learning about centuries in elementary school, right? Say this was like 1996. So you're in the year 1996, you're just learning about centuries, and you look at your year, the year that you're in right now, and you see the numbers 1 and 9, 19. And you would automatically assume, hey, this is going to be the 19th century. But that is incorrect. It is actually the 20th century because of this whole system right here. How 1 to 100 will be the first century, and 101 to 200 will be the second century. So you understand a little bit? So now that we understand a little bit, let's go back to the problem. So our problem is we need to increment, we need to round up the number, the decimal. If we get a decimal, we need to round it up. So what we're going to do is we're going to use a function called a math seal. So we're going to type down math.seal, and then we're going to add in our year divided by 100. And what that's going to do is it's going to round any decimal, no matter what it is, no matter if it's 2.1 or 2.9, it's going to round it up by 1. And with that, let's see our test results. Everything passes. So let's take a closer look at that. So you see our year input is 1905. our output would have been 19.5 or 19.05, somewhere around there. But with math.seal, it increases it up to 20, and we get the expected output. Same with test. Well, test 2 is 1700, which would have which would have returned the right number if we didn't have the math.seal, because it's 1700. 1700, 1800, 1900. Those would bring back whole numbers if we divided it by 100. So let's actually give you let's show it to you. So let's return year divided by 100, no math.seal, and we run the tests. 3 out of 9 of our tests would be correct, and those 3 would be the I'm gonna just call them whole numbers because I don't know what to call them, honestly. So see, test 2, 1700 would bring back the expected output. Test 4, year 2000, output 20, expected output 20. Test 6, year 200, expected output 2, and output 2. So there's that. So let's bring back the math.seal. And let's tweak this a little bit. Let's add some ES6. Let's refactor this to a little bit of ES6. And the reason why I'm pushing ES6 a little too far is a lot of newbies are scared of ES6, and I'd like to shed a little light. I want to give you like a little sneak peek of what ES6 is like. So we're going to show you guys an arrow function. And how we're going to do that is we're going to declare a variable called centuryFromYear, and we're going to equal sign I'm at. And then we're going to create an arrow function, and that requires 2 parentheses, then an arrow, which is the equal sign and the greater than sign, and then we're going to have our 2 brackets. And in the parentheses, we're going to have our parameters. In our case, it's 1 parameter, and that's going to be year. So we're going to type down year, and then the arrow function is basically function, and then we're going to put our output in here. We're going to put our code in here, basically. So we're going to copy this right here, this return math.seal, and then we're going to put it in here. And then that's pretty much it. We're going to remove this function right here, the traditional function, and then we're going to have this arrow function right here. And then we're going to run the test again to see if it's right or wrong. And as you can see, all the tests pass still. And yeah, that's pretty much it. I hope you like this video, and I'll see you in the next. Thanks for watching, and if you like what you see, click that like button and subscribe if you want. And if you want to follow me on Twitter, I'll have it in the link below. Thanks.